Okay, so the next thing we need to be able to do is actually how do we convert from Cartesian or rectangular form into polar form? So I've, clipped out the key sentences from your book here. So the angle theta between the line segment joining a complex number z to the origin and the positive x-axis is called the argument of z, or sometimes for short, A or G bracket Z, basically. The angle theta is anti-clockwise. So we're going anti-clockwise when we're reading that angle from the positive side of the x-axis. The length r of the line segment joining a complex number z to the origin is called the modulus. Now, we knew that already, so we're just going to continue to use the modulus the way we have before. So the polar form of the complex number is r bracket cos theta plus I sine theta, where r is the modulus of the complex number and theta is the argument. And then it just says by convention, theta is between negative pi and pi. So don't worry too much about that. So it's pretty straightforward, actually. So I'm going to do an example in each quadrant, and then you should be able to manage them basically after that. So let's start here with, say, for example, we do part one. So the first step is sketch it. So just any old sketch, just to get the idea of where it is. So 3 plus 3i would be in the first quadrant. So I'm going to make it into a triangle. So this is revision of trig now. We're going to put theta in there, so our mystery angle. Now, because it's 3 plus 3i, it's 3 over 3 up. So to figure out my angle theta using my trigonometric ratios, what I have to do is think, well, I have opposite and I have adjacent. So that's going to be tan. So the tan of theta is opposite over adjacent. So the tan of theta is 1. So theta itself, so I'm going to do the tan inverse of 1. Now, you could also look up your log tables here, your special angles table that we've used again in trigonometry, or you can go to your calculator. Now, can I just put in a little warning here? Your calculator should be in radians. So if it isn't, you need to go shift, set up, and then change it go to number 2. So shift, set up 2, and then obviously pick number 2, which is radians. So the tan inverse of 1 is it says a quarter pi, which is pi over 4. Now, you can also get that, as I said, from the special angles table. So the special angles table, just let me remind you again of the page number. 13, I think, is it? Yeah. So it's also on page 13 if you want to look up tan of 1, and you'll see it's 45 degrees or pi over 4. Now, because it's in the first quadrant, the important thing is the argument has to be read from the positive sense of the x-axis. So it has to be read from this bit here, anti-clockwise. So when I read it anti-clockwise, the good news is it is as is, because we're in the first quadrant. So when I read it from the positive sense of the x-axis, anti-clockwise, theta is theta. So job done, basically. Now I still have to find r. So theta is here. We'll figure out r here. So what is r again? Well, r is the modulus. So the modulus, remember, is the real squared plus the imaginary part squared. So that's all I have to do. The real part is 3 squared. The imaginary part is 3 as well, squared. So I end up with 9 plus 9, which is root 18. And then we can split that up into 3 root 2. Or again, if you're not sure, just pop it into the calculator and the calculator will tell you it's 3 root 2. So now all we have to do is piece it together. So it's r cos theta plus I sine theta. So my argument is 3 root 2. My theta is pi over 4. And that's it. That is polar form. So it's easier than you might think. Polar form is calculating theta, calculating r, and then piecing it together and putting it back into the polar form version. So that's it. It's obviously a little bit harder when it's in different quadrants. So I'm just going to run through a few examples. So this is all in your handout that I gave you yesterday. So let's say we do, maybe let's pick one here as well that has a root in it. So let's do part 3. So again, quick sketch, -5, 5 root 3. So -5 is roughly here. 5 root 3, I don't exactly know what that is, but I know that it's up here somewhere. So basically, I end up with that kind of a complex number. This is obviously or, because it's the modulus, it's the distance from the origin. If I turn this into a right angle triangle, I know that the distance is 5. Now, the complex number is -5, but you can just, use the positive version of that. And then the height, because obviously distance can't be negative anyway. And your theta is in here. Now, again, you have opposite and adjacent. So to get your theta, what we're going to do is we're going to do the tan of theta. Teachers often annoy opposite over adjacent. Now the 5s cancel. So I'm looking really for the inverse tan. So for theta, it's the inverse tan of root 3. So again, in your special angles table, if you find root 3, you'll see it's 60 degrees or pi over 3. So theta is in fact pi over 3. Now, we just have to be careful here because it's not the first quadrant. So if I read from the positive side over, do you understand that theta is pi over 3, but the argument is actually going to be pi take pi over 3. So in other words, pi is the whole thing. So pi is the full 180. Theta itself is pi over 3. So if you take theta from 180, so I'm working in radians. So if you've forgotten, just to remind you, pi is 180. So if you want, you can figure it out in degrees and then change it to radians if you're more comfortable. But anyway, just look back on trig if you've forgotten, but pi is 180. So I'm doing 180, take the angle, and that's what gives me the blue, what we call the argument. So remember, the argument goes from the positive sense of the x-axis to the complex number anti-clockwise. So it's this bit I'm interested in. So I then work that out. So I have, that's technically over 1. So that's 3 pi minus pi. So that's 2 pi over 3. Then I work out my modulus. Now this is the easy part. The modulus, we've done it many times now already. So for my modulus, which we're calling or in this case, is going to be the real squared. So the real was what again? Real was -5 actually, wasn't it? It was -5. It's not going to matter anyway because I'm going to square it. And then it's 5 root 3 squared. So that ends up being positive 25. Now be careful here. So again, do it out on your calculator if you're not sure. When you square 5, it's 25, but then the square root of 3 is 3. So when you go to do this, it'll end up being 75. So I'm just going to do it out on the calculator here anyway, just because I'm sure you guys are probably testing it out on yours. And yes, 75. So it ends up being the square root of 100, which is 10. So the polar form here is, remember, or cos theta plus I sine theta. So I fill in. So that's 10 cos of 2 pi over 3 plus I times sine of 2 pi over 3. And you're done.